We're going to solve equations with rational exponents. These are the steps that I'm going to use. If you want to stop the video and copy the steps down before we work the problem, you can do so now. I'll work our sample problem here. The first step is to isolate x to the power of 2/3. In order to isolate that, I want to get rid of the 3 on the outside. So I'm going to divide both sides by 3. That leaves me with x to the power of 2/3 equals 16. Now I want to get rid of this exponent here in this fractional exponent. So I'm going to multiply it by the reciprocal. Two-thirds times 3/2 is 1, so now I have x equals 16 to the power of 3/2. I can rewrite this in a radical, the square root of 16 to the power of 3. The square root of 16 is 4 to the power of 3, so my final answer is x equals 64. Now remember, I always want to check it back in the original just to make sure that I've done it right. So I have 3 times 64 to the power of 2/3 is equal to 48. I can rewrite this as a radical, the cube root of 64 to the power of 2. The cube root of 64 is 4 to the power of 2 is 16. 3 times 16 is 48. So my answer is right. In this one, remember the first step is to isolate the part that has the exponent. So I've got to do something to get rid of this -9. I'll add 9 to both sides, and now that gives me x minus 4 to the power of 2/3 is equal to 25. And remember, I wanted to get rid of this exponent, so I'm going to multiply by its reciprocal. And if I do it to one side, then I have to do it to the other side. So now I'm left with x minus 4 is equal to, I can change this to a radical, the square root of 25 to the power of 3. So x minus 4 is equal to 5 to the power of 3. And I evaluate that 125. Add 4 to both sides, so I get x equals 129. Okay, let's check it to make sure that it works. So that gives me 129 minus 4 to the power of 2/3 minus 9 equals 16. 125 to the power of 2/3 minus 9 equals 16. Change this to a radical, the cube root of 125 squared. The cube root of 125 is 5 squared is 25. 25 minus 9 is 16, and that is right, so this is my answer.